Welcome back. Let's now take a quick look at the C++ program structure. In the last class, we learned how to write a program, save it, compile it, and run it successfully. I hope you enjoyed writing your first C++ program. So, you already have had a good feel of the C++ program structure. All you need to do is to put all your understandings in the right places, and you will be on the right track to form a strong foundation in the C++ programming domain. Just cheer up. In this video, we will review what we learned in the last class. In the process, we will get used to some common nomenclatures and also understand the basic C++ program structure. This class will be more of theoretical in nature. But don't worry, I will take you through a quick overview of the most important aspects. From what we learned so far, the basic steps for building and running a C++ program follows this hierarchy. Start the C++ IDE. Write C++ program code. Save it in a specific location. Compile and run the program. And finally, view the output. We will now have a closer look at the first C++ program that we wrote in the last chapter. It was meant to print the message, "I want to be a programmer." The program can also be written as shown here. Have you spotted the difference? In method 2, we directly invoke the cout object by referring it as part of the namespace, std. So here, we did not declare the statement using namespace std, as we did in method 1. The std cout statement used in method 2 simply means like this: in the space labeled std, there is an object named cout, which has been inserted with a text message for being displayed onto the output screen. Let's now break down the C++ program code. Returning back to method 1 of the program code, let's dissect the code. Each line was briefed in the last chapter. Let's dig a bit deeper into them. On line 1 we wrote, /, my first program in C++. As learned earlier, it is the comment line, or simply, a rough note the programmer uses to write down some remarks. Comments don't get executed by the compiler, and so, this line is not converted to the executable file. C++ supports two types of comments. Number 1. // It is the one-line comment. Number 2. The block comment. It is used to write multi-line comments. Multi-line comments can be placed within /, asterisk, and the closing asterisk, followed by /. On line 2, we have #include IOStream. This line informs C++ compiler that while compiling, the object library named IOStream has to be included for reference of inbuilt objects or functions that are used in the program. Note that compilation means translating the program from source code to object code or to the machine executable code. IOStream is a library of predefined, reusable, special-purpose programs in the form of objects for executing input or output operations in C++. IOStream is just one among several other header files like CMath for math functions, CString for string functions, CCtype for character handling, and many more. Lines beginning with a #sign are directives to the preprocessor. Such preprocessor directives are indications to the compiler on what needs to be arranged before compiling. The #include IOStream is a preprocessor directive for the processor to include IOStream library before the compilation process. In some C++ IDEs, the header files have .h extension. Like for example, iostream.h, math.h, ctype.h, string.h, etc. On line 3, we have using namespace std. In here, it is declared to the C++ compiler that a logical space named std containing the cout object would be used in the program. The cout object, which is within the boundaries of std namespace, forms part of the IOStream library and it performs output operations. Let's now have a look at what the difference is between a namespace and the header file. The namespace is a logical area having a collection of special-purpose blocks of code that are part of a wider code library. For example, the namespace std contains the cout object and is part of the wider iostream header file. A header file is the actual physical storage, while the namespace is a logical classification. When developing huge applications where we use multiple libraries or header files, the namespace helps prevent different classes with same names being used by different developers. We will now have a look at line 5 and line 9. On line 5, we have int main function, and line 9 has return 0. Int main function is the point where all C++ programs start their execution. Int is the return type which informs C++ compiler that this main function will send an integer value to the compiler, indicating success or failure of program execution. Here, return 0 makes the compiler assume that this is an error-free program. There's an interesting note. In the given program, changing return value from 0 to 1, -1, 10.2, 10 halves etc. will still have our program work well as long as it's a numeric value. In the later C++ programs, return 0, return 1 and exit function play significant roles to identify normal from abnormal program execution exits. Let's not worry about it now. On line 7, we have cout, I want to be a programmer. The object named cout is an already compiled built-in utility program that streams, or sends in series, text messages onto the computer screen by means of stream insertion operator represented by the double less than sign. Cout is a standard output stream, belonging to the logical boundaries of the space, or namespace, termed std, which in turn is lodged within physical boundaries of the built-in object library, termed iostream. Next, let's review our understanding of the structure of C++ programming language. As we all know, a program is the set of sequential instructions given to the computer system for performing a specific task. Execution of any program begins from a named entry point, where processor control is transferred from the operating system to a computer program. In C++, the entry point for program execution is often the main function followed by an opening brace and the closing brace, within which a set of instructions are written. The operating system controlling your computer understands low-level language, but cannot directly understand C++ programs because C++ is a high-level language. The C++ compiler translates and converts the C++ program, or the source code, into machine language, or the object code. This object code is then run by the operating system to give us the desired results. The compiler knows whether a program has been translated successfully to its object code or not by means of the exit point return statement, which may carry a numeric integer or int parameter. For example, return 0, where 0 might specify an error-free code. The return value is a program execution status indicator that is handed over by the main function to its compiler. The data type of such a return value is specified on the left-hand side of main function. For example, int main function, where int specifies that the return value would be of type integer. If you don't need the compiler to know of program termination, you simply don't specify a return value at the exit point. But you may have to mention that the main function returns no value. For example, void main function, where void specifies that there would be no return value. Note that many updated C++ IDEs don't support the void main function. You just use main function by not specifying the return type, and don't have to write the return statement inside main function. The C++ Standard Library. The C++ Standard Library is a collection of pre-built programs that can be reused by programmers for specific purposes. These programs come under different headers. For example, input operations are done using the C in object, which belongs to the class named iStream. And output operations are done using the cout object, which belongs to the class named oStream. Both these objects, cin and cout, are stored in the input or output parent header file named iostream, from where it is invoked by the program code. You will be using several header files as you progress further in this course. Header files contain declarations of a set of classes and definitions of its library functions, which are used by the program to perform specific operations. As already seen by us, the header file iostream contains iStream and oStream classes, from which the cin and cout objects are used for input or output operations. What are preprocessor directives? Preprocessor directives are lines of instructions written in the program code, which are directions issued to the processor to make certain arrangements before the actual processing starts during program compilation. These directives are preceded by the hash tag. Here are two examples of common preprocessor directives. Number 1, #include IOStream. This processor directive is given to the compiler to include IOStream library for processing the input or output operations, which may be used in the program code. We next have the preprocessor directive, #define, pi, 3.1415. This directive is for the processor to define pi as 3.1415, so that, wherever pi is used in the program code, the compiler replaces it by the value 3.1415. What are C++ streams? The C++ stream library contains objects that manage input or output operations, as well as error handling functions like the ferror function. The stream represents a sequence of data or bytes that flow into or flow out of a program by way of files or I/O operations. For example, cin and cout are C++ objects that belong to the IOStream library for processing data which flows in from the input device or flows out to the output device. Similarly, the open function, close function, read function, and write function operations belong to the fstream library for processing data that comes into the file system or goes out from the file-based system. That's all for this class. In the next session, we will learn about variables and data types. Until then, take care.